All right, everybody, we're going to be talking about arithmetic series. All right, and I'm going to do a quick little review of what an arithmetic series is. I'm going to go back to my notes right here. See if I can go back over here. All right, these are the formulas that you're going to need. Okay, here's the arithmetic sequence formula. Here's the series formula, the geometric sequence, and the geometric series. You can pause that and write those down. But the very first problem that we did was right here. That was the very first problem. And what I basically extended it. I extended it all the way out to where there were 10 terms. So if you wanted to find the sum, basically the arithmetic series is the sum of all of these numbers in a sequence. And the sum of all of these turned out to be 100. But when I was working with my students, I said, hey, here's a little formula. The sum of an arithmetic series is, this right here is the first term. This is the last term. You divide it by 2 and you multiply it by the number of terms. And we figured out there were 10 terms. Okay? So our first term was the number 1. Our last term was 19. We divided that by 2 and multiplied it by 10, and we end up getting 100. All right? And so when you add all of these together in the calculator, it turns out to be 100. So that's what we're going to be working on today. So here we go. Arithmetic series. It says our first term is 2. All right, so here we go. Our first term is 2. Very first term is 2. Now here's the formula we will eventually use. The sum of this arithmetic series is the first term plus the last term divided by 2 times the total number of terms. Well, right now it says the sum of the first 335 terms. Oh no, we got to find the sum. We got to find the sum of the first 335 terms. Whew, holy cow. All right. So, we don't know the last term. So we got to find the last term. So we got to use what's called the arithmetic sequence. So put A of n equals the first term plus a common difference times n minus 1. So right here, this number 2, I'm going to plug that guy in right there. So we got A subset n equals 2. Now it looks like they're saying the common difference, everybody, the common difference is a negative 3. So right here I'm going to put minus 3. And it says 335 terms, so I got to find the 335th term. So I put 335 right there. And what this is going to do, all right, what that's going to do, that's going to give me my last term that I need. Okay? So right now, they gave us the common difference. The common difference is negative 3. They gave us the first term, and the first term was 2. And I had to find my last term. So I'm going to use the calculator right now. I'm going to do 2 minus 3, parentheses, 335 minus 1, which is 334. So it looks like my last term is negative 1,000. So my last term is negative 1,000. That's my 335th term. So now I'm going to use this formula. When I say this formula, I'm talking about this guy right there. So here we go. S of n equals the very first term, which is the number 2, plus our last term, which is negative 1,000, divided by 2, times the total number of terms, which is 335. I'm sorry, I can't do that in my head. So I'm going to go to my calculator. I'm going to hit alpha y equals enter. I'm going to open up a parentheses. I started with the number 2, I believe. Yep. Make sure. Yep, 2. Okay. Minus 1,000. Close that parentheses. Divide it by 2. And then I'm going to multiply it by 335 terms. Holy cow. So it looks like my answer is right there. Negative 167,165. All right, so I'm going to write this down right here. I'm going to put that in the Khan Academy. Negative 1, there we go. Negative 167,165. All right. Hopefully I did everything right. I did. Woohoo! Next problem. All right, I like it. I had a student who had this problem. Hopefully, I'm sure you got it right though. All right, he's pretty cool though. I can't give names because, you know, confidentiality. But he's one of my. If I was allowed to have a favorite student, he'd be one of them. Okay. Oh, he's not even smiling. Oh well. All right, so here we go. Here's our first term. Here's our last term. I don't know how many there are, but that's our last term. All right, we got to find the sum of all these guys. So I could keep doing it if I wanted to until I got to 5001. All right, but we're not going to do that. We are going to find how many terms are in the dadgum sequence. Or series, sorry. All right, so our last term is 5001. Our first term is the number 6. Our common difference, it looks like these guys are going up by 5. So that's our common difference. So I'm going to put a 5 right there. Now, n minus 1, that's what I'm going to solve for. I'm solving for n. All right, so we go 6 plus distribute, get 5 times n minus 5. 6 minus 5 is 1, so I got 1 plus 5n. We're going to have to take away 1 from both sides. If I was just doing this, I'd know the answer is 1,000, but just got to keep going through the problem. 5,000 equals 5 times n, and after you divide both sides by 5, n is equal to 1,000. What does that mean? That means that's how many dadgum terms are literally from here all the way to the end. There's 1,000 terms. So now we use our summation formula, all right, our arithmetic series formula, which is the first term plus the last term divided by 2 times 1,000. So I got to type this in the calculator. All right, so type that in the calculator. So once again, alpha y equals, enter, take our first term, which is 6, take our last term, which is 5,001, close the parentheses, divide that by 2, multiply it by how many terms there are in the whole series. Holy cow, I wish that was in my bank account. All right, 2503, wow, 2,503,500. Yeah, not there yet. I'm a teacher. Oh well. So, go over here. 250. Oh, hold on. 3500. 3500. All right, that's the sum of all of them. Nailed it. Let's do one more. Oh, well, golly, why would we get an easy one? All right, so this is summation notation. Basically, they're saying there's 425, all right? And all you got to do is just plug this in. Now, when you're plugging it into the calculator, I'm not sure if it accepts K or not. I always use X for the summation notation. So I'm just going to put X equals 1. There's going to be a 9. Instead of a K, I'm going to put an X minus this. And there's going to be 425 of these terms. So I got to use summation notation. So how do you do that? You go alpha window, number 2. All right, I'm going to put X, put a 1, put 425 right here, and here I'm going to put 9X, and then what was it? Hold on, minus 3,219. Okay, minus 3,219. Press enter, and I get negative 553,350. So I'm going to type that in carefully. Let me look back at it real quick. 350. All right. So on that one, it's going to be this is using sigma notation, so that'll be pretty easy. All right. So what's the most difficult ones to do? The most difficult ones to do are when you actually have to do what? You have to find how many terms there are. So here's basically the formulas that you're gonna need for all of the series and sequences that you're going to do. All right, so hopefully if you're not sure how to do it, if you make sure you go back and you review how to use this arithmetic sequence formula, so eventually you can use the arithmetic series formula. And that's it. Good luck.